In the event that we erase the boundaries, the most captivating celestial body recognize is the one that might be extraordinary in our sky. It is this one Betelgeuse. Betelgeuse is a massive red supergiant star, and if you were to position it where our Sun is, it would extend all the way out to the orbit of Jupiter. This massive, extremely unstable star is on the verge of exploding. However, it's not as straightforward as it may seem. In the cosmos, these colossal events like the most extreme supernova could shake everything we observe and even things we don't. Though we cannot see it clearly, Betelgeuse is considered a symbol of a red supergiant star, typically much larger than our own Sunday. Brian Cox, along with other astronomers, believes it might explode in a supernova soon. People have grown increasingly concerned about what's going to happen because the James Webb Space Telescope has been capturing remarkable images of the star. When exactly will Betelgeuse erupt into a supernova, and how significant will the impact be on Earth? Let's delve into a star in the magnificent Orion constellation, which shines so brightly that even ancient civilizations noticed it. The splendid star Betelgeuse resides on the eastern shoulder of the Orion constellation, ranking as the second largest star in Orion. Its name derives from this location, marking it as a shoulder star. Betelgeuse is likely one of the brightest stars visible in the night sky. In addition to its brilliance, the star emits an unusual red hue which, as we will explore, signals potential danger. Humanity's study of Betelgeuse. Humanity has long studied Betelgeuse. The Greek astronomer Timacharis observed it long ago. At that time, the first thing people recognized about stars was their color. Timacharis noted that the star seemed to have a reddish-orange hue, an alarming indication. In recent years, scientists have been studying the star with even more precision, and they now have a much clearer understanding of what makes it so strikingly luminous. One of these factors is that the star undergoes substantial variations in brightness, fluctuating by as much as 0.6 magnitudes. Betelgeuse is a variable star, meaning its brightness changes periodically. In 2019, researchers discovered some new behaviors in the star that had never been observed before. Even though Betelgeuse didn't stop shining completely, its luminosity significantly decreased. It dimmed to a level of around 1.6 magnitudes, prompting experts to investigate why such an irregularity was occurring in one of the brightest stars in the sky. According to their findings, Betelgeuse could explode as a supernova at any given moment. Brian Cox, a renowned scientist, shared this alarming assessment. As a distinguished professor of particle physics at the University of Manchester and the Royal Society Professor for Public Engagement with Science, his opinion carries weight. He also presents popular science TV shows and writes books, making his perspective well respected. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could erupt with little warning. To support this claim, the James Webb Space Telescope has provided substantial evidence. However, several peculiarities about Betelgeuse have raised many questions. Betelgeuse's mysterious behavior. Betelgeuse's mass is nearly twice that of the Sun, which supports its classification as a supernova candidate. Generally, stars with at least several times the Sun's mass are considered potential supernova candidates. Scientists have used different tools to investigate Betelgeuse, such as the James Webb Space Telescope, JWST, the Laser Interferometer Gravitational Wave Observatory, LIGO. These instruments have uncovered mysteries surrounding the star, though much remains unknown. Betelgeuse was born millions of years ago, and since then the star has been offering strange signals that keep its future uncertain. What did scientists discover? They detected peculiar light waves emanating from the star, raising further intrigue. But this wasn't the only strange occurrence. Betelgeuse is a variable star fluctuating in brightness. There were reports that Betelgeuse had regular darkening episodes akin to sunspots on our own Sun, but the cycles were different. It shifts between bright and dim phases twice as rapidly as it once did, another odd sign that Betelgeuse is misbehaving. The Great Dimming of Betelgeuse. In February 2021, the star's dimming cycle reached a brightness band of 1.61 magnitudes. This was not long after the Great Dimming event of 2019-2020, which saw the star reach its lowest level of brightness. Many experts believed this was a sign that the star would explode within the next 100,000 years. However, when Betelgeuse brightened once more, things became even more bewildering. Physicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics noted that the star was now 150% brighter than usual, making it the seventh brightest star in the sky. The final phase of a massive star. Not every star radiates the same red glow that Betelgeuse does. This glow marks it as a red supergiant, which is the final phase of a star's life before its death. This red hue results from a surface temperature of around 3,500 Kelvin, significantly cooler than the Sun's outer layer, about 5,500 Kelvin. Since Betelgeuse is cooler than the Sun, it radiates less energy per unit of surface area, even though it is much larger and on the brink of exploding. Today, multiple telescopes are focused on this mysterious dimming event, trying to gather more insights. The James Webb Space Telescope has been one of the most valuable tools since its launch in 2021, helping astronomers gather new data about Betelgeuse. The future of Betelgeuse. The James Webb Space Telescope has observed that Betelgeuse experienced an enormous mass ejection, roughly 400 billion times more significant than a typical coronal mass ejection from the Sun. Scientists have also observed dust clouds forming on the star's surface, appearing like leaves in space, an odd but fascinating finding. Despite Betelgeuse's inevitable demise, no one knows the precise moment when it will explode. However, when it does, it will be the first supernova witnessed in modern times since Johannes Kepler's observation in 1604. Even though Betelgeuse's supernova will be an awe-inspiring cosmic event, it will not pose any direct threat to Earth because Betelgeuse is over 600 light-years away. Nonetheless, it will provide a valuable opportunity for scientists to study the final stages of a massive star's life and the phenomena associated with such an explosive event. Betelgeuse's eventual supernova will not just be a scientific curiosity, but also a reminder of the vast and unpredictable nature of the universe. Stars like Betelgeuse play a crucial role in the life cycle of galaxies, enriching the cosmos with elements essential for the creation of new stars, planets, and potentially life itself. Until that day comes, Betelgeuse will continue to shine, offering astronomers a glimpse into the mysteries of the cosmos. Betelgeuse, the unpredictable giant. As astronomers continue to monitor Betelgeuse, its fluctuating brightness and unusual behavior raise more questions than answers. The dimming events between 2019 and 2020 were some of the most extreme ever recorded, sparking debates over whether the star was approaching its explosive end. While some researchers initially suspected that a massive dust cloud was responsible for the sudden drop in brightness, others theorized that it might be an early signal of core collapse. One of the most crucial aspects of Betelgeuse's instability lies in its internal nuclear processes. As a red supergiant, the star has exhausted most of its hydrogen fuel and is now fusing heavier elements like helium, carbon, and eventually iron. Once iron accumulates in the core, nuclear fusion can no longer generate enough energy to counteract gravity, leading to a catastrophic collapse that results in a supernova explosion. When Betelgeuse eventually explodes, it will be one of the most spectacular astronomical events visible from Earth. The explosion will produce an immense burst of light radiation and high-energy particles, briefly making the star as bright as the full moon in the night sky. For weeks or even months, Betelgeuse's supernova will be visible during the daytime, marking the first such event witnessed in modern history. However, despite the sheer power of the explosion, Earth will remain safe due to Betelgeuse's distance, roughly 600 light-years away. Scientists estimate that a supernova must be within 50 light-years of Earth to pose any real threat. What comes after the explosion? Following the supernova, Betelgeuse's remnants will transform into either a neutron star or, if massive enough, a black hole. The explosion will also release heavy elements like iron, oxygen, and carbon into space, contributing to the cosmic cycle of star formation. These elements will mix with interstellar dust and gas, eventually forming new stars, planets, and potentially even life. This process highlights the critical role that massive stars play in the evolution of galaxies. Without supernovae, dispersing elements into space, planets like Earth, rich in iron and carbon, would not exist. The mystery of Betelgeuse's behavior. While Betelgeuse's supernova could occur tomorrow or in 100,000 years, astronomers remain uncertain about the exact timeline. The James Webb Space Telescope, JWST, and other advanced observatories continue to monitor the star, collecting data on its temperature, brightness, and mass loss. One recent discovery suggests that giant convective cells on Betelgeuse's surface could be causing its erratic dimming rather than an imminent explosion. The star's outer layers may also be ejecting dust clouds, temporarily blocking its light from our perspective. Despite these uncertainties, astronomers are hopeful that ongoing observations will eventually unravel the mystery of Betelgeuse's fate. When the moment finally arrives, it will be a once-in-a-lifetime event, offering an unprecedented glimpse into the life and death of massive stars.